I hope this is working. Okay, no. Oh, okay, okay. Hello, everybody. I hope you can hear me. I hope the music is okay. Please let me know if the audio levels are okay. Hi, Kubio. How are you doing, man? Welcome to the stream.
Oh, okay, okay.
I
Hello,
also had
everybody.
the stream not muted,
I hope.
so you will hear some echo for a while, but it should be okay now. Okay, I think everything should be alright. I'm actually still kind of eating. I have some lettuce on the side. You might see me snack on it for the next few minutes. I was waiting. I think I've been spending the last 2 years thinking of that joke. I'm kind of surprised it took so long for someone to make it, but I'm really happy you did, Scaffolds. How are you doing, man? I saw you dropped your new devlog. I haven't watched it yet. I've been hard at work like all last week, and today was kind of hectic. But yeah, that was pretty cool that you started posting again, and I'm really excited for the direction your game is taking. I've seen something. I've seen something on Twitter. Like, I'm not completely oblivious of what's going on, but yeah. How are you doing, guys? So, let me open up Unity. So this will take a few minutes. We all know Unity is not the most performant, the fastest booting application. Like, I make the joke in my head every time I think of myself as Watip, because of course I do not refer to myself as Watip. But I think you were the first one to make it. Like, I kind of made the joke when I titled the game jam What a Jam. But this is the first time I actually received it from someone else, so that was pretty fun for me. Hey Hamza, how you doing? Yeah, it's gonna take. Well, first of all, I hope I did not mispronounce your name. Second of all, yeah, it's gonna take a while. Yeah, it's booting up now. It's booting up. I will also have to boot up Visual Studio, so everything is set up for when we actually start playing with stuff. That's very good. It's exciting. You enjoy making the game. That's pretty good. I would say that's the whole, like, as long as you're like, if that's like you work in a software house and you're making the game for that software house, you're allowed to not be like, not enjoy that. But from what I understand, this is also a side project for you, like a hobby that maybe, yeah, if you can monetize it's better, but it's not your main gig. So enjoying it is probably key. I kind of stopped making The Last Day of Summer because I was not enjoying it anymore. It was like so stressed by trying to cut it down to have it fit a more approachable scope for one person, that I was like, yeah, this is not the same game I was working on and I want to make. So I did not really enjoy it anymore. So yeah, I'm happy that you are enjoying it, because that's the main driving factor for me. Okay, so the first thing I want to do is open up a new window in Chrome and go over with all of you what we done last time by looking at the VOD. Yeah, my game was very open-ended, and like, in retrospect, it's a very good way to have it like skyrocket out of scope. No, I wanna open the playlist, not the video itself. Let me get the mouse pad. View full playlist. The last. Where are the other live streams? I don't know. Okay, I have no idea where the other live streams have gone. Let me find them. Okay, YouTube Studio. Well, I guess I can show you in Unity. I don't really need to do that on YouTube. Okay. So. Okay. Big thing you're doing is small demos that aren't the full game but are fun experience in its own. I think that's a good like game plan. Like it's a good plan for you to make something that keeps your interest in the game like high and lets you visualize where you are going. So that sounds like a really cool way to approach it. Okay, so last time we ended up with this kind of tool that allows us to create a Bezier curve that is controlled with two anchors, 1 and 1, and two control points. One is here and the other one is here. And this curve can be both sampled like in time, and that's what the I guess what rings. Okay, these rings are not useful anymore, so I think I might be going to hide them for now. Okay. Oh. Why is it not adding? Was it not? I have no idea. Okay, never mind. Okay, great. It updated. And again, I commented out too much stuff. Okay, it's going pretty slow today. That's great. I need to do something about this. Okay, great. So we have this curve. This curve can be sampled along its function, I guess, along its curve in a certain number of points, and we can do that both in time and in space. What does it mean? Basically, if we sample the curve in time, we're gonna get points that are further apart where the derivative is like greater, and closer apart when the derivative is closer, like is smaller. But if we want approximately evenly spaced points, we're gonna have to sample it in space. So what we do here is actually use this function to calculate for what percentage of the way in on the curve, for each percentage, what time corresponds to that. So if it's 0, it's gonna be 0. If it's 1, it's gonna be 1. And then we're gonna use a lookup table of length that we sampled along the curve to calculate what the t for that s is. And I will make sure to make those videos, the VODs, public, so if you wanna look more into it, we go over that in those VODs. Then from the curve, starting from the curve, we sample the points and we should raise down from these points, so you can see the intersections here where we have the cyan ray. I hope you can see it in the video. The cyan ray, which is basically the tangent to the curve in this point, and the magenta ray, which is the normal to the curve in that point, we should raise down until they intersect with terrain. And you can see here we have a new coordinate system for each of these points. And what we did last week was, let me open up a Google Chrome page and go to my Twitter, because I think I posted it there. Oh, look at this. It's a scaffold post. Profile, okay, yeah, I now don't know how to use Twitter. Okay, so what we did last week was what is going on here? Was create this way of spawning simple meshes starting from those points that we sample. So you can see, if I can like load, stop the video here. I need to pause it. Okay, the quality is terrible. I have no idea why it's so bad. But basically we are shooting down rays from the curve, intersecting the terrain, calculating the coordinate system for that point, so that the forward axis, which is basically the z axis, the local z axis, is oriented like the tangent of the curve. The x axis is oriented like the normal of the curve. The y axis is oriented like the up vector, so 0, 1, 0. But all of this is also rotated to fit the normal of the intersection with the terrain. So if the terrain is more steep, yeah, I'm looking at the camera. So if the terrain is more steep, we're gonna have a ray hitting it from upward, from up above, and then the normal of this point is gonna be like this. So we're gonna interpolate and rotate all the coordinate system based on that. And we were spawning 2 simple quads to just show that something is happening there. What I did in the meanwhile was implement exactly what I wanted to do. So I'll show you. This is my tool to create a procedural fence. You can see that the poles of the fence are getting placed on the terrain, and that the fence also generates some planks that go across and intersect the poles, and we can like make them more dense. We can make the fence larger, and I think this is very, very cool. So you can also see the wireframe of the meshes. We're basically using scaled cubes to do all of this. And yeah, so by moving everything here, we are just like randomizing this, and I can also randomize the placement of the planks. So you can see that I can change here the seed, and the positioning of the planks changes. And honestly, this is I am super excited. It's pretty basic. Oh, nice fans, thank you, Scaffold. I would say this is pretty basic, but for being pretty basic, I am very excited about this. It can also, like, you see, if the terrain, if an intersection is not found, so if the terrain ends and the rays are shot in the void, we're not gonna have errors this time. Last time I left some very ugly code that caused a lot of errors, but the planks are just not gonna be placed because it doesn't make sense to connect 2 poles that are so far apart. And we could also randomize whether we want a plank to actually be there. So let me try that. we can I'll show you the procedural cube code. Basically what we're doing is generating vertices and triangles. As someone that has manually placed fences in game, I think this yeah, I'm so happy that you say that, because I've been going for years placing fences manually, and it's honestly something that is so frustrating. If I take like any screenshot from the last day of summer, you will see fences. And placing fences is terrible. When you edit the terrain, it's terrible. Here, what I can do is, yeah, I just go here, raise the terrain a little bit, go back to the curve, and it updates. I think this is, thank you, but I am super happy with the results. Like, it's exactly what I was hoping to get. So here we have our cube generation code. Basically, we're generating 24 vertices, and you will say, why 24 when a cube only has 8 vertices? Because we are actually generating 4 vertices per face. Because if we do not want to share the normals and have the sharp edges, like not the smooth shading but the sharp flat shading, we actually have to generate them like this, I think. And also, maybe it's not just for that, but if we want to unwrap the cube and texture it, like you would do in Blender, where faces are not all like adjacent, you're gonna have 24 vertices. And I'm pretty sure that the default cube also has 24 vertices when it comes to the GPU, like to the rendering aspect and not the modeling aspect. So yeah, that's what we're doing. So I have my I calculate based on width, height, depth, center, and like the relative coordinate system. I calculate the 8 points, A1, B1, C1, D1, which are these 4, and A2, B2, C2, and D2, they are these 4. I have some a small reference system here that I use to not go crazy while doing this. Then I'm creating a vector array, a vector 3 array that contains 4 vertices per face, and this was kinda, it was not super super intuitive. Hey Khalid, welcome to the stream. Happy you made it. How are you doing? And yeah, after generating the vertices, and you can see here they are like, I'm copying the same vector because it's a struct, so I can afford to copy it multiple times in the array. And then we are just generating the triangles that make up the faces of our mesh. So for example, y plus, it's this one, it's gonna be A2, C2, B2, A2, D2, C2, because we are connecting them in clockwise order. And what I'm doing here, I have a custom class that's called mesh part data, because I'm gonna unite all of these like cubes, and I have a cube for each pole and a cube for each plank in a single mesh. So instead of calculating everything at once, I have my logic to calculate just what I need for one cube, and then I am like merging them. So if I go to my procedural fence script, you can see that we take the projected points for from the curve, and what we do for each point, we find out what the forward, up, and right vectors are, generate a cube for the pole, which is basically just gonna be scaled and oriented with the coordinate system that we found, and then we're gonna add it to the final mesh. Then if it's not the first ball, and if it's not null, basically we're just gonna generate the plank by calculating. What I ended up doing here is using the direction between the current point and the previous point and normalizing it to have a forward vector. I'm using the average of the up and the right vector to orient on to calculate the up and right vectors of our planks, and that's basically what allows us to have them like be placed like this. And then I slightly randomize with the RNG the plank positioning. Yeah, I remember that the situation is not so good. I hope you're doing well though. I hope everything's as good as it can be. I wish you the best, bro. Yeah, thank you. The music is Stream Beats, as always. Been around for a while. Okay, yeah, so this is what I've been doing, and this is how it's coming along. So this one, I would say, is actually pretty it's actually done. I wanted to try making a another kind of procedural geometry. Like, no, that's not what I was trying to say. I wanted to make another type of fence inspired by the Viking settlement fence. So let me open another window here. Let's say Viking village fence or something like that. Yeah, exactly like this. This would be so cool. So if you look at this, we can sample the curve and then generate the poles like this. So just create meshes that are like this. I will probably have to work this like out better and manage to find a way to create, like, to automatically create dense points here along the curve. But for the moment we're just gonna have a higher vertex count, and I think that's good enough. Also, I think I will be publishing the code on GitHub at the end of this live, so if you wanna take a look at it, improve it or anything, feel free to do so. Okay, so what I ended up doing, let's duplicate the curve. Let's fence. Okay, and this is gonna be wall. One. I have my procedural fence inherit from a procedural curve mesh abstract class. So what I'm doing here, what I'm gonna do is go here, mesh, and I'm gonna create a new C# script, procedural Viking wall, and I'm gonna have it inherit from the same class. So what I need to do is just copy all of this. Now I will copy some of this over. I should have had it in the base class, but I did not bother doing that. I will be honest with you. And I'm gonna just say override generate mesh, and now I can, instead of having that, I can put this here, remove this, Okay, great. And we will proceed and create a new mesh by writing the code for that. So, okay. Let me have some of the lattice I was talking about earlier. Not really that bad of me to hit like this, but I'm very hungry and I really didn't have dinner. Okay, so what we can do here is, instead of having pole width and height, we're gonna have a public float min radius, okay, min radius and max radius. We're gonna set it to like 0.4 f and 0.5 f, and I would say public float mean height is equal to 1f, well 1.5 f, max height is equal to 2.5 f, something like that. And what we're gonna do is also create a new, I already had a cylinder here, but what I'm gonna do is create a new C# script, like a new class that's gonna be like procedural cylinder spike, and let me change the name here, procedural cylinder spike. And let me also separate the mesh part data into its own script. Add new struct, using Unity engine. Rename mesh part data.c#. Okay, and also using system.collections.generic. Okay, need to reset Visual Studio because it's always buggy. And let's go on with that. What time is it? I do not have as much time as usual. How is it only 23:30? 11:30. Is it 11:30 for real? Oh yeah. I thought it was way later. Okay. So let's see how much we can get done here. Let me copy over the code from here, and I should probably use some form I would say some form of inheritance here as well, but I'll go with that right for now. using the Unity engine. And let me rotate the mic. So here. Hey Lynx, how are you doing? Welcome to the stream. Let me show you what I did between last stream and this one. You can already see something. You can already see it. Let it compile. It should be done. Let me deactivate this. Let me activate this. And look at this. I did it. I completed my procedural fence. You can see how it gets placed on the terrain. Edit the forms. If I move it like out of bounds, it stops placing the blanks. I could like write some code to automatically calculate the spacing for the poles, and that would probably be a cool way, like a cool addition, but I'm not gonna worry about that for now. I want to try something else, and I'm now doing a Viking wall. But yeah, this is I'm pretty happy with this. I think it came out pretty well, and I can also randomize the placement of the planks in the fence. Yeah, it's a fence. I'm super happy. Like, on the first iteration of the last day of summer, placing fences manually was a pain in the ass that you cannot imagine. So this is, I am pretty happy about this, like pretty stoked. And now I'm just copying the code for the cubes that I'm using for that fence, and making a cylinder with a point. This is gonna be a bit harder though, I think. Maybe not. We'll see. So, float. This is not gonna take a width, a height and depth. It's gonna take like a float radius and a float height. Okay. And the float spike. Radius, height, spike. So here I'm also going to add public float min spike percent is equal to 0.05. Max spike percent is equal to 0.15, something like that. So what we're gonna do is here, when I come into this class, I'm not going to this was the cube, like the graphic I did for the cube to calculate the points. Let's try and do this for the cylinder. So the first thing I want to do is have, and for the moment we're gonna like have a fixed number of vertices, like of rings, of segments in the rings of the cylinder. So the cylinder is going to be something like this, like, and drawing with ASCII characters is not always like the most convenient thing you can do. But it's kind of working. We're gonna have something built like this. So it's gonna have a section with this shape. Whoop. Okay. And then we're gonna extrude it vertically, like this is XZ section. And we're gonna have the X, Y, or ZY section be something like this. So we're gonna have our cylinder extruded along the y-axis. Oh, something like this. Let me draw it. It's not like the most comfortable thing to do. Okay. So our cylinder is gonna be extruded along the y-axis. Yo, is that? Hi, Sophie. How are you doing? Yeah, this is not a new t-shirt. For those that don't know it, I wear this t-shirt a lot. Okay, so basically we're gonna have the spike be something like this. So we're gonna have like this, the main part of the cylinder here. We're gonna generate 6 quads, basically 12 faces along here. So these could almost be something like this. Okay, and then we're gonna have 6 triangles do the point, basically the spike. This center is gonna be called, well, I think I can actually empty this. I can empty this. I can empty this. I can delete all of these. I can delete this. Okay, don't worry. I'm not gonna be live for much longer. Like, I'm probably gonna be live for another 30 minutes and then go to bed. Radius, height, spike, origin, and this is gonna be called origin. So let me think about this. What we want to do is calculate the 6 points. So we're gonna call these A, B. Well, I'm gonna call this A, B, C, D, A, B, C, D, E, and F. And to calculate this, we're gonna say that vector 3A is gonna be origin plus a matf dot cosine, and let's see, this is gonna be the x-axis let's see, something like this. So this is gonna be the x-axis and this is gonna be the z-axis. So cosine of vector float angle is equal to 360f divided by 6. Do I need the angle f in radians? It's my question. Let me check the documentation real fast. Okay, so unity matf dot cosine. Let's see if this takes the input angle in radians. So what I'm gonna do is gonna say float angle is gonna be this times matf dot cosine, no, matf dot deg to rad, so degree to radians, angle times right plus matf dot sine of angle times forward. And what we're gonna do here, well, I could probably do this by creating our, let me think of this. Let me think of this. So what we want to do is actually do this in a loop, I guess. And we want to generate A1, A2. I'm guessing this is gonna be A1 and A2. A1, A2, well, B1, B2, and A2. We want to calculate this, so what I'm gonna do is say for int I is equal to 0, I is less than 6, yeah, I plus plus. What I want to do is say float angle A angle is gonna be 360 F divided by 6. F divided by 6 times I times modf dot deg2rad, and here we say float B angle is gonna be the same so we can say float angle is gonna be this without the I. And we can say that A angle is gonna be angle times I, and B angle is gonna be angle times I plus 1 modulo 6. Okay. Is this required? I don't know, I don't think so. Okay, so we're gonna have like 0. What is 360 divided? So 0, 60, 120, 180, 240, 300, and then again 0. But we're also gonna have for this phase we're gonna have 0, 0, 60 and 60 for this phase. Now we're gonna do this phase and it's gonna be 1, so it's gonna start by 6 from 60, 60, 120, 120, and it's gonna loop here and go back to 0. So now we want to say float A cosine is gonna be modf dot cosine times cosine of A angle. Float A sine is gonna be modf dot sine A angle. Float B cosine is gonna be modf dot cosine B angle, and float B sine is gonna be modf dot sine of B angle again. Okay, mod D I wrote mod F. Okay, mod F dot sine. Now we are ready to generate the vertices. We're gonna have 4 times 6 vertices for the faces of the cylinder. Then we're gonna have 6 triangles for the bottom face and 6 triangles for the top the spike. So let's say that vector 3 vertices is equal new vector 3 array, and it's 24 plus 6 plus 6 is gonna be 24 plus 12, which is 36 vertices. Let's say int vert counter is equal to 0, and here we can start adding the vertices to the array. So vertices of I is equal to something, and I'm gonna let's start with 0 like this, and we'll say vertices vert counter plus equal 4, and instead of I here we got to say vert counter plus 1 plus 2 plus 3. Okay, so the first one is this one is going to be center, origin plus vector 3, well, not vector 3, but the right vector here, so right times a cos. I think we can even add the radius here, so times radius times radius times radius and times radius. Okay, so a cos plus forward times a sine. Then we're gonna use we have this one, then this one, then this one, then this one, so we're gonna have origin plus right, and I think I can just copy this over and say instead of a cos and a sine, b cos and b sine. And here what I want to have is just the same code with a b here, of course, but instead of having this be the same exact position, we're just gonna add the up vector multiplied by height plus up times height, and this should be enough to generate our side faces. Now we want to generate the 6 vertices. So what we can do here, I would say, is going to be find out where those vertices are gonna be. So the first 24 are going to be these vertices here. So what I can do here is say vertices of 24 plus I is gonna be a, basically just equal to a. And I think this should be enough. And I think we might even have to add 2 new vertices. And also of 36 of 30. This is gonna be, well, the first 24 are gonna be, yeah, okay, this is correct. So we're adding the top and bottom rings now to use in their own faces. Now what we want to do, and my brain is exploding right now, is add 2 new vertices for the top and the bottom. And what I want to do is just say vertices of 36 is going to be origin, and vertices of 37 is going to be origin plus vector, well, plus up times height plus, well, height times plus spike times height, something like this, because I'm using the spike as a percentage, or I can just say spike and calculate that in another like another point in the code base. Okay, and we should have all of our vertices actually in the mesh. I would say something like that. Let's now calculate the triangles, and this is not something that I really look forward to. So we're gonna keep an eye on these two drawings. So let me just fold the code here and see what can we do. So let's say A, B, B, C, C, D, D, E, E, F, F, A. Then we're gonna have bottom 6, spike 6. Okay, I think we can do this. So for the spike, we can actually see it as something like this. So let me make this a little bit shorter. This is gonna be something like this. Okay, we're gonna take this one and connect it to this one and connect it to this one and connect it, and that's a triangle. So let's try with these ones first. They seem the easiest. So we can always start from the center. So the center one is the 37th, and then we're gonna start from 30. So it's gonna be 30, 31, 32, 33, 34, and 35. So in case of this one, it's gonna be 37, 31, 30. Then we're gonna have 37. Well, I need a comma here. 32, 31. Then we're gonna have 32, 33, because it's gonna be 31, 37, 32, 33, 32, sorry. Then we're gonna have 34, 35, and we still need 2 more. 35, 34, and we are, oh yeah, and we're gonna have, no, I'm not sure of this. Hey Edo, how are you doing? I am consuming my own brain. So 31, 30, 32, 31, 33, 32, 34, 33, 35, 34. This should be a 30, but that should not be a 36. So let me see here. It makes sense that they start from that. Oh my god. Yeah, don't worry, Kubio. Have a good day. Thank you for stopping by. So if this is gonna be 37 and these are gonna be 30, 31, 2, 3, 4, 5. We're gonna have 7, 1, 0, 7 through 1, 3, 2, 4, 3, 5. Oh, it's gonna be 30. Okay, yeah. 30, 35. And let's just use these for now. Let's go to procedural fence and keep this to the side, I would say. Okay, and try to build the Viking wall. For the moment we only have the spike, but we're gonna calculate, like we're gonna show it and see if things are working, and then we're gonna go on with the cylinder spike triangles. So it's gonna be a pain in the ass to work with. Okay, so here what I want to do is create a new random number generator, and I'm just going to copy these two. Then I will say for int I is equal to 0 while I is less than points dot length I plus plus. We're gonna say the same if points index I is equal to null. Continue. And now we're gonna do this. So vector 3, I can do this here. I don't care about optimizing the performance to these like minute details. So origin is gonna be transform dot inverse transform points index y dot position. Then we're gonna have a vector 3 up. Well, I'm just copying these 3 lines here, and we should be fine with that. Now what we want to do is say let's calculate a radius and the height and the spike percent. So float radius is going to be a new float for the RNG dot next double radius radius t. Let's call it radius t, and then we're gonna interpolate. Then we're gonna have a height t and a spike t. And now we're gonna say float radius is gonna be matf dot lerp from min radius to max radius t. Float height is gonna be a matf dot lerp min height max height t. And float spike is going to be height times matf dot lerp min spike percent max spike percent spike t. And now we're gonna go on and say that partial mesh data is gonna be procedural cylinder spike dot generate, and we wanna pass the radius, the height, the spike, the origin, the right vector, the up vector, and the forward vector. we're gonna say final mesh data dot add partial mesh data. And at the end here, we're gonna say mesh filter dot, well, mesh filter. Do I not have a mesh filter? Oh yeah, here. Sorry. Mesh filter dot mesh is equal to final mesh data dot bake new. And this should be all we need to generate the spikes. Oh, yeah. I need to disable this and enable the right one. Yo, it's working! Okay, this is fucking cool. I took the wrong rings here, but this is cool. This is very cool. Okay. It's sort of working. Let me like make the minimum like lesser, the max higher, the mean height, the max height. Like we can make this, and you can see that the generation here. And so just this is just cones, and it's pretty cool. I am really happy with this, and we can randomize it. Okay, this is very okay. I am super excited about this. Let me figure out what I did wrong with the vertices here. Oh yeah, we need to add plus up times height here. So now they should be very high up and more coherent. Okay, great. Max spike percent is gonna be higher, something like that. I don't know, something like this. Like mean spike percentage should be higher. Okay. Now we will create the cone. Like, let's create the base. And for the base, we want to go counterclockwise because we're seeing it from below. So for the base, we're gonna have 36 be the first vertex in each face, and we're gonna be starting from 24. This is gonna be 24, so we're gonna have 36, 24, 25, and we should be 24, 25, and we're gonna have 25 and 26, and we're gonna have 26 and 27, and we're gonna have 27 and 28, and we're gonna have 28 and 29, and we're gonna have 29 and 24 again. So if I now generate the mesh, let's see how it goes. Yeah, you will see that they are not visible because you are looking from below, from above, but from below they should be like this. And what we can do is actually offset these cones to be slightly like into the ground, and I would say that could be a good idea. So let's go and just origin. Where is the origin? Okay, so let's go here and say origin minus up times 0.1f, something like this. And now this should be in the ground. Okay, yeah, something like that. I'm guessing it's fine. And now let's do the boring part, which is the 12 faces. But it should go pretty easily. So we're gonna unite, like, we're gonna have 0 connected to 1, connected to 2, 0, 1, 2, and then we're gonna have 0. Wait, so no, it's 0. So this is gonna be 0, this is gonna be 1, this is gonna be 2, and this is gonna be 3. So 0, 2, 1, 0, no, 3, 1, 2. Okay, this should be the first phase. Alright. Yeah. Okay, this works. So now we're just gonna have to add 4 to this other 5 times. With some care here. Let's go. Let's say, no, I don't think we need even to have any care here. So 4, 6, 5, 7, 5, 6. And this is gonna be 8, 10, 9, 11, 9, 8. Let's see how this is going. I would say this is going okay. The third one is not perfect. Let's try and fix that. Why is it not perfect? Like +2 minus 1, +2 minus 1, +3, plus minus 2, +1. Oh, this is supposed to be a 10. Okay. So 12, 14, 15, 13, okay, 15, 13, 14, 16, 18, 17, 19, 17, 18, and this is gonna be 20, 22, 21, 23, 21, 22, and we should be done. We should be done. Let's go. We did it. So now let's tweak the parameters here. Let's have the largest ones not be so large. Let's have lower spikes. Something like this. Let's have them be slightly less tall. Okay, let's randomize this. Something like this. We can bring this up a little bit. Okay, and let's bump up. Well, we can also rotate them, but let's bump up the vertex count. And we have our Viking wall. This is, you have to admit that this is so cool, and it was super simple to build. I'm so excited about this. Let me record. I'm gonna send a clip. Oh, I do not have my phone with me. I wanted to send it to my brother. Well, I'll just do it like this. Okay. Give me 1 second. I'm kinda excited about this. I want to have his feedback on this, because he was very pumped about defense the other day. But yeah, I would say it's all for today. This was pretty cool. Okay. And this is the procedural Viking wall. Yeah, I need to think about my pronunciation a bit more. But yeah, so this is how it's looking. We can slightly bend it to make it more organic, I would say. Hey Sophie, we're done. I'm basically ending stream right now, but welcome back. This is the result of today's work. And just like the fence, this can be adapted to any terrain. We can make them more dense, more sparse by changing the vertex count. 45 was a good number for this side of the wall. Yeah, and where is the main? Okay, so if I move this here, it gets cut off, so it does not proceed into the void. And yeah, this is something I'm pretty excited about, and seems like a good ending for this experiment. I will probably post a video on this. I will cut up the live streams and see if I can make a video out of this. But yeah, pretty happy about this. Let me know what you think. And I think I will be ending stream for today. It's been quite fun, and I need to find time to code. So yeah, this is a good compromise for me. Yeah, so let me close up some of the things I opened, mainly Visual Studio. And yeah, so I'm gonna be posting the code up on GitHub if I remember. And I'll probably be exploring more of this kind of stuff because I find it pretty funny. Not funny, but fun too. Yeah. This said, let me change studio mode here. Let me change the text from the starting soon to ending stream, ending over. Thanks for watching. And yeah, let me go back to my scene. This said, thank you so much, and see you next time. Oh, okay. Yes, Italian. Hi, Taigoro. I'm not talking too much Italian here on stream to make sure that anyone that logs in. My English is abandoning me, so I should talk Italian. But yeah, I'm Italian. Ciao, come va? This said, welcome to the stream. And this said, I'm sorry, but the stream is over because I am too tired. You will be able to check everything once YouTube publishes it in the live stream playlist. Thank you for watching. Have a good night, everybody, or a good day, wherever or whenever you are. And see you next time.